Hello, Internet. Welcome back to hybrid live coding. Is it just hybrid live coding workshop? Sorry, I'm a bit tired.
Hybrid live coding interfaces workshop.
That's the one, yeah, there's some interfaces, yeah. So we're about to get started again. We're starting a bit early because Victor had some problems with his audio yesterday, so we're starting early to move his presentation here, which is why you can see me, because I was moderating the session with Victor, so I am going to continue moderating him and then pass you over to Shelley and then Jack to do the rest of the day. Okay, I think this is all working. Hello, Iris. Can you hear me okay in the stream? Problem is there's like a 20-second delay, so maybe I should just assume that that is working. Oh, it is working. I can unmute. Yeah. Okay, so Victor, I shall make you presenter. Would you like to step into the light by sharing your webcam? Good to see you.
Hi. Good to see you. Sorry for the delay and the disruption.
No problem at all. I mean, yesterday was surprisingly glitch-free, so it's a shame that you were on the receiving end of the only glitch. But I think it all went really well apart from that. And looking forward to seeing what you've prepared for us in the meantime.
Sure. So let me share a video. It's a pre-recorded presentation. So
nice one.
Hi, Victor Zappi here from
I'll mute myself and hand over to you.
You are now muted.
And today I'll first talk a bit from Northeastern University. And today I'll first talk a bit about on-the-fly programming of chip synthesizers. And then I will introduce a new technology designed to make algorithmic chip-tone music. So let's introduce chip synths. Chip synths are integrated circuits found in vintage video game consoles and computers, especially from the 80s, like the NES on the right here, or the Commodore 64 on the left. And they are dedicated to synthesize music and sound effects on such machines. This is an inside of a... Okay, there's no audio in the video?
The video seems to be muted, so I don't know if it's just that.
You are now unmuted.
How it is possible? It's probably, so Shelley, maybe you have to unmute it on your end. It's actually a good piece of information. So I think every user has his own way to control the volume. And
okay. Sorry about the interruption.
No problem. It's okay. Let me pull it back from the beginning.
You are now muted.
Hi, Victor Zappi here from Northeastern University, and today I'll first talk a bit about on-the-fly programming of chip synthesizers, and then I will introduce a new technology designed to make algorithmic chip-tone music. So let's introduce chip synths. Chip synths are integrated circuits found in vintage video game consoles and computers, especially from the 80s, like the NES on the right here, or the Commodore 64 on the left. And they are dedicated to synthesize music and sound effects on such machines. This is an inside of a Commodore 64, and from now on we'll focus on the specific computer. And here we can find its chip synth, which looks like this more in detail. The C64 chip synth is called the Sound Interface Device, or simply SID. It's famous for its signature sound, as well as for its limitations, which are shared with nearly all synth chips. Yet, these very limitations have guided the musical practice of chip-tune musicians and programmers for decades. And this is in line with what discussed by several works in the literature, as well as by other presenters here in this very workshop. So let me share with you a practical example about limitations that influence music making in the case of the SID. This is a visualization of the output of the SID when it plays back the soundtrack of the game Arkanoid, composed by Martin Galway in 1986. As you can see, the SID has only 3 voices, which means that 3 oscillators can be active at a time, and the 4th one can be activated literally via a hack that allows to play very low quality and short samples. The chip is also equipped with an analog filter and supports voice modulation, allowing for a certain timbre variety. But it's clear that patterns and layering tend to have a more prominent role in this music. And this brings us to the next section of the presentation. Why coding on these chips? Well, as I said, their limitations foster algorithmic approaches like layered and evolving patterns, and in addition, these chips are inherently autonomous. So we don't need to continuously feed an audio buffer, and as soon as a command is dispatched, the chip will go on playing that sound, let's say forever, or until we send another command or we pull the plug. And finally, they were designed to be controlled via the programming languages found on board on vintage computers, which in many cases had on-the-fly interpreters. So this seems a perfect combo for on-the-fly programming, so let me demo the live coding capabilities of the C64 when controlling the SID. Unfortunately, I don't have access to a Commodore 64 right now, but I have an emulator, which allows me to code in C64 BASIC, and it also includes a software SID. I'm running a very simple program that initializes the SID and creates some variables and code snippets called subroutines that may come handy to control it. I can directly access the memory location of each voice, and in particular here I'm accessing the first voice, and I'm setting some bits so that basically I activate a sawtooth wave on it. More conveniently, I can use a subroutine to stop it, to send basically a gate off, and I can do the same with a gate on. Now, while the sound is still going, I can continue coding and change my program, and I can even concatenate comments. For example, here I'm going to switch to voice 1 instead of voice 0, and then I say save this value in this variable, and then please use it to change the frequency of the current voice, and also send a gate on comment to it. Now we have 2 voices, so the second voice was added to the first one, while the first one was still running. Then I can use a subroutine to actually kill everything. It's fun. However, we quickly hit a brick wall here. For example, let's say I want to create a pattern, something like this, something that generates some kind of value, 3 values, from 0 to 2, with some kind of a function that determines the timing of between each event. Well, I can do pretty much whatever I want here, create called nodes, gate on, gate off, change parameters, but as soon as I run this pattern, I won't be able to change my code anymore, because the CPU is not capable of handling multi-threading, and this is a common problem to all vintage CPUs. So it really becomes pretty difficult to go beyond these very simple examples that I showed you. It is possible, but it's pretty difficult. This is one of the reasons why chiptune musicians and programmers veer towards different musical paradigms, more in line with the limitations and the specs of vintage CPUs, like crackers, for example, or more recently, fully-fledged 8-bit DAWs with piano rolls and synth presets. So at this point, I'd say that it would be great to see how far live coding can be pushed on these devices when using a modern laptop rather than vintage CPUs, and possibly when running a dedicated language like Super Collider. Which brings us to the last point of this presentation. How to live code chip synths. How do we make technologies belonging to different eras communicate? And here comes the technology I'm working on. It's an embedded platform built on Bella, here, and that can host an authentic chip synth, in this case a SID, harvested from a Commodore 64. It comes with a C++ library linked to Bella's source code that emulates a vintage CPU and grants bidirectional communication with the SID. The library exposes functions to access all the parameters of the synth in, let's say, an intelligible way. For example, we can directly specify voices without the need to remember their memory locations, and we can express their frequency in hertz instead of binary numbers. And the same is true for gather functions, and every operation grants sample level precision. The first application I designed on this platform is a simple OSC MIDI server that allows any remote client connected to Bella to communicate with a chip. This can be used with Super Collider, and indeed here I have a simple patch that showcases some of the possibilities unlocked by this setup. A quick disclaimer, I'm no expert in Super Collider, so this is very basic stuff. I will first activate a MIDI and OSC client that I previously made. They're both very simple, but they will allow me to send some kind of test message to the chip. Some kind of hello world MIDI signal. And we can actually hear that the seed is there and responding. And now I can start leveraging basically some basic features of Super Collider, some constructs to create patterns. That is, I define a BPM. Here I have a pattern on voice 2. It's very quiet, but I can change it on the fly if I want. Make some variations. And then let's switch to OSC. Let me select voice 1. Let's find some kind of slow attack and gate it. And here we go. While the pattern is running, I can continue coding. It's great. Now I can leverage other features in Super Collider. For example, here I'm using OSC, an envelope, OSC envelope, to create some kind of LFO. Oops, not an LFO. This is an LFO. Okay. Stop it. You can read the latest value, so I go here with this comment. I retrieve the frequency at which the voice is right now. It's in here. I see voice 1. It's 196 Hertz. It's saved automatically in this variable that I can use, again with an OSC envelope, to create a nice sweep, pitch sweep, from here to, for example, 298. Let's set a filter if I want. Can kill pattern 2. So basically this concludes my demo, it concludes my presentation too, and even if only a subset of the possibilities available in Super Collider are currently accessible via this application, I guess you got an idea of the direction I'm taking. I see this as a successful test, and my plan is to fully integrate the library in Super Collider's engine as a plugin or as a UGen. And I hope this work and this presentation sparked a little bit of curiosity towards chip synths. And I'm looking forward to gathering any feedback from live coders. As I'm not an expert live coder, I'm just entering this fascinating work. Thank you so much for your attention.
You are now unmuted.
Sure I am. Yeah, sorry, it takes me ages to activate and deactivate my stream, my video stream. Well, yeah, well, it sounds very different. I mean, many people in the chiptune community know this. That you can use an emulator. It's a kind of a yeah, like a software emulator of a chip, but it's kind of a trade-off. First of all, the sound is a little bit different, but more importantly, you kind of you skip most of the constraints that make chiptune music interesting in the first place. Like the approach to composition and performance is really mediated by the limitations, not just in terms of the number of voices that you have, but also the glitches, the hardware problems, and the memory constraints, and all this stuff that it's not there when you have a VST plugin. You drop it into Ableton and you start to flood it with MIDI. Yeah, that's actually true. Yeah, but they are not manufactured, but there are some clones out there. Some of them are pretty similar, very close to the authentic ones. But the cool thing is that there is a new wave of FPGA clones, and these are very good, very reliable, and they do a great job in replicating all the idiosyncrasies inherent in the production and the actual manufacturing process. I have to say, it was not difficult for me to find some chips on eBay. Yeah. Not really. I mean, the documentation of the C64 and the different revisions of the chip of the SID are available, and this is true for I would say all of the chipsets that belong to the 80s and 70s era. So it's pretty straightforward. Maybe the language is a little bit outdated. Maybe some pieces of information are not in line with the engineering standards, but I think that any hacker can quickly catch up and do it. Yeah, sure. I mean, I'm not I cannot consider myself a live coder. As I said, I'm just entering this practice, and so maybe I have a kind of a skewed vision of it. Maybe I'm missing some of the aesthetics or some of the practicalities. So my project is totally technology driven at this point, but it would be great to have some kind of feedback to see what kind of features are already needed to make this appealing to a community of people that are already into making music on the fly with languages. For example, I'm not sure whether I should include this as a UGen or any other kind of way integrating this in Super Collider, or maybe there are other ways to actually leverage this bidirectional communication that the platform is capable of and place it in the context of live coding. This is kind of only my intuition, let's say. Maybe other people may have a better grasp on this. No, I mean, I don't expect an immediate feedback. I mean, as I said, like maybe even just a spark of curiosity would be enough to create some connections. I have to say, the project is open source. I'm gonna release some kind of alpha version soon. It's open hardware, open source. I just need to refine some details and have something that is not a prototype. And maybe by doing so, people will have a better access to this field and to the project. That's actually a really good point. I never thought about it, and I think it's an amazing perspective. And another idea that I had is to collaborate with people that used to program these chips in the 80s and in the 90s with trackers or other sorts of means, and propose them the use of live coding to see if their practice is somehow influenced by a different paradigm. It may be interesting.
Sorry, yeah, I've just realised that my voice was muted for YouTube, so you haven't been getting my words of wisdom. But the important thing was that you got Victor's important words of wisdom. I think the only useful thing I said was that a good way to get feedback on live coding environments and ideas is by running workshops, because then you get good feedback from workshop participants, especially people who are coming to live coding without preconceptions. Sorry, I have quite a delicate audio routing system, and I forgot to unmute myself in both places. So normally presentations are 10 minutes with 5 minutes questions. So we're actually over time, but that's okay because we're not scheduled to start the next presentation until 5 o'clock. So we should leave some time for Shelley to introduce the next section. But if anyone has another question, here's one. So Konstantinos says, what is an expert live coder? What would be more convenient for this would be an expert SID performer, maybe, which kind of is what you just said, I suppose, in a way, Victor.
Yeah, I have to say I don't know what an expert live coder is, and as I said, watching this community from afar since now, until now, it's even more difficult for me to truly understand what I'm asking for. But I think that people that have experience with these technologies back in the days may have a very, very interesting insights about it. Thanks.
Yeah, I think as someone who's been around the live coding scene for a while, I don't know what live coding expert means either, and I think it's interesting that this quite imaginary scene people talk about as if it is a real thing and a real practice, but I'm still trying to get my head around people taking it at all seriously. So yeah, okay, so I think there might be a question coming in from Simon. He's typing away. There we go. It would be interesting to see how you would articulate the process visually in a performance. That's something that crossed my mind as well, actually. If you're using a SID chip as opposed to another synthesizer, how do you actually get that across the audience? What's going on visually or sonically?
Well, one thing that I didn't mention in the presentation is that you don't necessarily need to detach a chip and put it on the platform. You can actually use some kind of cables connected directly inside of the computer or video game console. So you may imagine the design of an instrument that contains this original technology that is very visible on stage, and you just control it with your own laptop or your own interface. The system is based on Bella, so you can even add sensors and actuators and machine learning support. So there's really a lot of space for creativity, even from a visual point of view, which may mean like creating an instrument that touches upon the aesthetics of the 80s, or even connecting to more complex devices to project or to and sorts of stuff. The problem is that as soon as I start to say, yeah, you can do pretty much whatever you want, well, that we lose the meaning of making music and making art, because it doesn't work like that. You really need some fixed aesthetics, and so I didn't want to say that.
Yeah, it's all about
not fixed, but some kind of very self-driven, what I would say instead.
Mm-hmm. Very good. Okay, well, thanks very much, and thanks for working on that video overnight to manage to get everything together in that 10 minutes.
Thank you.
And yeah, nice one. So now I'll hand over to Shelley, I suppose. We've got 5 minutes now until we start the scheduled program. So yeah, maybe everyone should have a bit of a stretch at this point. Limber up, ready for 3 hours of discussion to come. Is it 3 hours? I think.
Yeah.
It is. Yeah.
Yeah, I think stretching and getting a glass of water, those are good things to do with this 5 minutes.
It's really important to stay hydrated. If it's sunny where you are, you should probably stand outside and get. I hear that vitamin D is really important for resistance to viruses and things. So catch some rays if it's daytime. But don't get your laptop wet if it's raining. Keep that indoors. Okay, we are officially filling time.
Other random advice.
I know, we can turn the multi-user whiteboard on and then we can do some drawing to entertain the people on YouTube. Let's invent a new instrument together. I hope that's not rude, Evan, whatever that is. What's it? I can't tell what that is. Seems to be someone shooting something at me. I don't know. Someone with a Mohican. Okay, I'm being looked at. You don't get this on TED Talks, do you? Right. I don't know what to say. Okay. Some sunshine, that's nice. Sunshine on a robot.
There's a speculative live coding interface design going on here.
Yeah, it looks like it's becoming sentient.
Yeah.
It's not happy. Right. Nice Algorithmic earring. Okay, I think it's time to start introducing the next session. I'm afraid I'm going to have to turn off the multi-user whiteboard and clear the annotations out of respect for the next presenter. So sorry about that. Enjoy the artwork. Nothing's forever. Best not to get too attached. There we go. Right. I'll hand over to you then. See you later, everyone.
Yeah.
You are now muted.
Yeah, that was a nice meditation on the ephemerality of creative expression. Great. Thanks, Alex, for that session. That was great. And we're moving on to instruments, part 2. We had a really great session yesterday where we explored 5 different live coding based instruments and thought about failure and limits and sort of the tensions between tech terminology and creative terminology and all sorts of other interesting topics. And I'm sure today's 5 talks will be equally as interesting. And so we are going to start with Mark Santalucito. And in the interests of time, feel free to introduce yourself before you start the talk.
Great, thank you. So I'm just going to switch to this presentation. I'm going to assume everyone can hear me, otherwise put something in the chat and yell at me. So I'm going to be talking about live coding sequencers with program synthesis. And to start, I'm just going to share a video. Okay, here we have our live coding web drum machine. And broke. Do that again. Okay, here we have our live coding web drum machine. And we have 2 panels. On the left, we have the code. And the code is a JavaScript function. And the JavaScript function is going to generate a beat B. And that beat corresponds to what we see on the right here, which is the pattern in the step sequencer. So we have 2 ways of interacting with this. We can either write code directly, or we can directly manipulate the pattern here in the step sequencer. So I'll start by just clicking the step sequencer. And what we see is that some code has been automatically generated. So the code we've generated here is a bit complex, but what it's saying is that basically I just want to create an array of length 16 to have a whole array here. And I'm going to fill it with 1s, and then I'm going to cut out everything after the first index, after the 0th index. So from 1 to 15, I'm going to fill that with 0s. So this looks kind of like overkill for now, but this will make it easier for us as we continue to add to this pattern. So the next thing that I'm going to add is another beat here. On the 3rd beat of this 16 beat pattern, you can see that the code that we've generated has changed. So the code we've generated now is saying rather than just returning the constant 1, we're going to return 1 minus the index mod 2. And so that's giving us this pattern here. So let's just run this. We're getting these 2 beats. Now we're still splicing out everything after the 3rd beat. So let's stop doing that. And we can see how that pattern continues on for the rest, how this pattern generalizes over the rest of the 16-beat pattern. Okay, so the other thing is that we don't have to stick to this. We can take this, we can start changing it. So if we have this, we can say, well, actually, you know what, I want to fill this with 1s. Or 2s. Or whatever we want. So, right, this is the way this step sequencer works is you have an array and the values are either 0 for empty, 1 for a medium beat, or 2 for a strong beat. So this is just JavaScript. We can write whatever you want here, as you've seen. Let's see this in action with a different pattern. So here I'm going to start working on the hi-hat pattern. Again, we've just got this 1. If we had a 2, it would look like this. And 0, actually it solves it by saying, okay, well, I can just return the index, which is not so interesting. So let's say I want this pattern that looks like weak, strong, and I think this is going to generalize correctly. So we've got this pattern going on now. Now let's say maybe I want it, but I don't want it for the whole thing, so do something like this. Cool. And so let's add a kick pattern now here. We've got our kick drum just on every 4 beats. And so you can see here that the code it synthesizes actually can get fairly complex when it needs to. This one's generalizing the way we expected. Now what's interesting is that if we can't find a solution, if we add a note in here and it's not able to do synthesis, what it's going to do is its best. So here we have, I've added another beat on second beat, the first index here. And our system is saying, okay, well, I wasn't able to take your change and integrate it into the rest of your existing pattern. Whereas up here, if we were to click here, let's just add this. It says, okay, yeah, I know how to fix that. Now this rhythm 5 is just always 1 for the range that we care about. Let's just go back to what we had before. But in the case that we can't figure this out, it's just going to say, well, I want to make sure that the code on the left here is always in sync with whatever's going on in this pattern that you're directly manipulating. So I'm just going to put a direct array index, and the same thing will happen if we put a value randomly in here. So the other thing that's important to note is that we can we're not limited to just these templates. So all the code that we've generated so far falls into this sort of a nice template of saying, okay, we've got a map of some value that we generate, and then we fill the rest of it with some value. So far we've only seen 0s, but it could be 1s or 2s as well. But we're not limited to this. This is still, we can write any kind of JavaScript we want. So instead of having a 2 here, we might have a random value. So we could write random like this. And so you can see on every beat, this value gets a new random value. And we could do this anywhere we want. Let's put this here. Now this is not something we could synthesize because it's random, so it's not something our program synthesis could figure out, but we're welcome to write any sort of code we want, as long as it's valid JavaScript and produces these 16 arrays of length 16 with the values 0 to 1. And this is where we're at with our live coding drum machine. Okay, so thanks for listening to that. I'm just going to take a little bit of time and talk about a few more details about how this is working. So this is using something called program synthesis using SYGUS. SYGUS stands for Syntax Guided Synthesis. And the way this program synthesis works is that you define a grammar of allowable functions, and then you're trying to generate a function that satisfies some set of constraints. So this falls into a space known as SMT solvers, or satisfiability modular theories. It's kind of like SAT solving, if anybody came across that. And so there's one tool called CVC4 that allows us to use this SMT solver CVC4 to solve these SIGUS problems. And so the main challenge is actually not quite so much in the actual synthesis and how synthesis happens, but in defining the space of allowable functions and the constraints. And so Evan had a question here. Previously, we saw the constant effectively 2 + 2, and it was, well, what's going on there? And I think Evan also pointed out, this makes sense. So you've defined a grammar that doesn't have the constant 4 in it, but it does have the constant 2 and has the operator plus, so we can reconstruct that 4. So let's just take a look at a high-level overview of the approach I'm taking here. So let's say we have this pattern here that we want to synthesize. What we're going to do is split each track into independent synthesis problems. So we're going to be solving each pattern as its own synthesis problem. And what we're going to do is generate example constraints based on the time index and the note value. So here for Tom2, we have f of 0, the 0 time index should have the value 1, f of 1 should have the value 0, and f of 2 should have the value 1. And so these are the constraints. And now we say, okay, I need to find a function that fits these constraints. And so what we're going to do, just to keep the synthesis in scope, is we're going to prune synthesis by removing large subsequences of common values. So from in Tom2, we see all this empty space. So we're going to say, okay, well, those are all zeros, so let's not worry about those. We'll deal with those separately later on, focus on synthesis of the complicated parts. So from this, we're going to put this into our SMT solver. We're going to get a result back, and we translate that synthesis result into a map, as we saw over that pattern array. So some of the limitations with the current approach is that each pattern is unrelated to other patterns, which is not quite as expressive as we would like. The generated code templates are very predictable, which is not so exciting. And the other issue is that because each of these are treated independently, this doesn't scale well when you run synthesis synchronously, as I'm doing right now. So there's some opportunities for expansion here. So I'm just going to hop to this last slide. So the code is available online, open source. It's just using JavaScript, pretty easy to get running. So what I'd like to do is connect this to a hardware drum machine. It's a little bit easier to test at the moment when it's in software. But some of the future questions are, what are the directions we need to focus on to improve synthesis to make it more usable? Also, how do we synthesize control of continuous values? For example, the sliders that control the pitch of the drums. And I think the real deep question here is, what is the right interaction model? Should we be overwriting user code as we saw before? That's sort of problematic because if we present synthesized code as an option instead, that prevents this annoying autocorrect code changing sort of thing, but it might make the experience less smooth. So I think my question to the community is, how do we build this interface so that it enables live coders to have multiple ways of interacting with their computational object, but it also isn't getting in their way like a sort of clippy situation. So with that, I'm happy to take questions. Thank you. Forgot to put my webcam on.
That's all right. Thanks, Mark. That was a super interesting presentation. I really enjoyed the way your system combines like the complexity of algorithmic design with sort of the transparency of a sort of sequencing interface. It's really nice. I wondered if you could say some more about the motivation for the project.
Yeah, the motivation really came from the fact that I'm originally a trumpet player, and I really love that sort of visceral interaction of being able to get my hands on an object and make music through touch. And I always felt like when I was live coding, I was missing that a little bit. And so I wanted to find a way to bring those two worlds together a little bit. And then also my PhD work was in program synthesis. So I was like, I wonder if I can actually do anything useful with this.
Great. There's a question from Alex. Have you thought about making a DSL for rhythm rather than using JavaScript?
Yeah, that's a really good question. My initial prototypes, before I actually implemented anything, I had been imagining a DSL for the rhythm. The catch that I ran into in the implementation was that the synthesis needs to work with very low-level integer primitives. So that being said, there might be some ways to have some built-in primitive functions that I then can interface with the SMT solver. So yeah, that might be a nice idea. I did like the idea of having it be raw JavaScript, just to make it a little more transparent, so that people don't have to learn a DSL that I kind of half-assed. But this is an important question, I think, for sure, moving forward once this works a little bit better. Looks like we haven't, sorry.
Evans just made a comment. I'm curious what you think the patterns say to the performer, how you recognize meta patterns and similarities, upbeats, downbeats, and if there's a way to specify that using a different, maybe more domain-specific grammar or just a musical pattern-like terms.
Yeah. So ultimately, I think this pattern interface that I have where you're just clicking on those buttons is all right, but I have a Novation circuit, which I really like as this hardware interface for sequencers. So, but maybe you're talking more on the code side. So I see Alex mentioned, as a performer. Yeah, I don't have the answer to that because I have not really performed much with this myself, and no one else has used it either. So hopefully I can get this online, or you guys can download it and try it out and let me know more of what you think. Yeah, I think there's so many questions in terms of what makes this actually usable. And the biggest thing I'm concerned about at the moment is how do you give users control over their code while also using that synthesis to help them out without overwriting them. I'm just always very cautious of ending up like Microsoft Clippy.
Yeah, so we're out of time now, but I think, yeah, I would also be quite interested to try it out. And if people want to try it, then go to the GitHub and give it a go. And also carry on talking about it in the Top Lab forum. So yeah, thanks, Mark, for your talk.
Thank you.
We will move on now to Kate Sicchio. Kate, are you here? Hi. Let me just make you presenter.
Great.
Yep, great, you're presenter now, so you can go ahead and load your slide.
Cool. Hello, everyone. I hope you can hear me okay. This might be either short or just very scattered brained as a presentation, and also a 2-year-old might run in at some point. So just bear with me as I present. So yeah, I'm going to talk about agency and live coded choreography. So I'm a choreographer. I've been using live coding as a way to make work. Basically, I think since 2011 was when I first started working in this way. So I'm going to talk a little bit about the role of the dancer in this kind of work, sort of looking at what we call like traditional choreography, dance improv, algorithmic choreography, and then live coded choreography. So also in this, I'm going to be talking about this idea of agency. Sorry. Sam. Sorry, we have a 2-year-old here. All right. So agency in this case is just a really simple dictionary definition, which is the capacity to act in an environment. So in this, the capacity to act is the decision making around executing movement, and the environment would be the choreography of a dance work. So traditionally in dance, we have probably the most structured and hierarchical kind of work, which is ballet. And someone who I think epitomizes that is George Balanchine. What we see in this work is we see really strict rules and set movement for dancers, and they get repeated the same way over and over again. So, Sam, stop.
Yeah.
All right, so we have, I actually wanted an image for this slide. That's a cartoon by Edward Gorey with 2 audience members looking at the season for New York City Ballet, saying, oh, this year there's only 27 swan lakes and 21 firebirds, meaning that these are constantly repeated, these ballets, in the same way. However, there is this like slight notion that they might be different with different performers, in that they do put different principles in the leads, and people do, when they buy their season tickets, we'll see the same ballet twice with different performers in the lead. So that's like a small token of agency we would find in these more traditional choreographic works. Sort of the opposite end of the spectrum is dance improvisation. So this is a photo of an improviser named Nancy Stark Smith, who recently passed, who was really influential in contact improvisation in particular. But this can range. Dance improvisation can be sort of an open score where you're just moving in a space, sometimes with others, or it can have like a rule set that you're going to interpret as the dancer. If like the traditional choreography is seen as like hierarchy with a choreographer and telling the dancers what to do, dance improvisation is usually seen as more equal, because the dancer is in fact helping to write with their body what's happening on stage. And then to jump to sort of algorithmic choreography. So this also has a range, just like we just saw with traditional choreography. So one of the main things, one of the first instances of this is Jeanne Beaman's work. So her first choreographic, she's like kind of the first who used a computer to make choreography in 1964 with her piece Random Dances. This is a photo of a different of her pieces actually, where basically she found that dancers were sort of scared of technology, which is still a thing that happens today. And so this is a photo of a piece where she was making fun of that, where she put like a fake mainframe computer on stage. But the choreographer I'm more interested in doing early algorithmic choreography is Analívia Cordeiro. So this is a piece from, she's a Brazilian choreographer. She made this piece in Brazil in 1973. M3X3. And it's like super complex in terms of it was mirroring movement that she was having the computer generate, as well as basically instructions for how to film it, because it actually was a video piece. And actually this piece is shown a lot more in video art context than it is in dance context, which is super interesting. But in terms of the movement that she was having the computer sort of generate, one of the things she says about it, and this is something that has stuck with me in my work, is that the dancer is free to describe the trajectory connecting the positions, meaning that the computer can only spit out like sort of certain ideas, and then to connect them, you still need a human. So now we see this agency coming into play again. These ideas really came forefront for me in my work when I did this piece, which was called Vibe Shirt. So this is actually a performance from International Conference of Live Coding when it was in Leeds. This is a dancer who I work with frequency, Tara Baker. And in this piece, she's wearing a shirt that has sort of vibrating motors on it that I am live coding those motors to buzz, basically right, left, or both, and then duration. And based on that, she is interpreting that into instructions that is up to her how she interprets it. So the human is interacting with there's two humans interacting with the computer in this case, and they're both making choices. So why is agency important, and why is it important that the dancer have agency? So live coding is about the transparency of human decisions. It's about public thought and changing law. This means that the dancer too should be allowed these privileges in displaying their human thought. They are not a machine, but simply responding to a machine, just like the coder. They are co-authoring the work in real time. So in the past, I've described this piece as a duet for coder and dancer. And while it is a duet, I wonder if the dancer is also a live coder. And I do have one more slide, which is like my current project. This is Tripsicode, which is also this idea of like dancer plus coder on stage. And in this case, the dancer is responding to images that are then made into patterns. There's this other part of Tripsicode, which I'm sort of trying to figure out too, which is actually the code is on the screen right now, which in some ways makes it more live coding if you want to share your screens that way. But it makes it problematic in terms of like, then the dancer gets even more choices. And yeah, and actually that can be overwhelming, and they might have, there's too much to respond to in that case. And maybe they want less in terms of co-writing the piece. So I'm gonna end there so I can take some questions. So thanks.
Thanks, Kate. That was super interesting. While we're waiting for questions to come in, I just wanted to ask, do you have some discussions with the dancer beforehand in how they're going to interpret either the code or the vibration or the images, or do you just leave it up to them to decide in the moment?
Yeah, so now I've gotten to the point where I've worked with a lot of the same dancers on different projects over and over again. With Tara, it's usually very open. It's usually a very brief discussion, like, here's the system. Like, so she's actually the first to perform with Tripsicode. I don't have documentation of that right now, but her first question was, what do I do with the text? I know I can respond to images, but what do I do with the text? That was her very first thing. And I was like, it's up to you. You're the first one doing this kind of thing. But we do have that dialogue about pieces, but I do leave it intentionally very open. Or sometimes we set a game plan to help the audience understand it a little bit more. So particularly with Tripp's code, the first few rotations of patterns, so like the images come up and there's like maybe 3 different images that keep rotating through. And the idea is that the dancer will actually somehow incorporate those exact shapes for maybe the first few minutes of the piece. And that way the audience can see the connection that they are actually interpreting what's on the screen. Then after the first few minutes, they are completely allowed to do what they want with the work.
Yeah, let's move on to Alex's question, which is interested in the fake mainframe. Oh yeah, that was like super cool. When was that piece from?
Her work is from the 60s. So I don't know if that piece is from the late 60s or early 70s, but it was in response to her actual algorithmic choreography, which she did in 1964.
Oh, yeah, that's super cool. Sorry, Alex's actual question. In algorithmic music, human is sometimes really underplayed, with composers like David Cope pretending their software is autonomous when they're selecting and editing the generated output. Other examples of fake dance performances. He said, sorry, that question is a bit scrambled, trying to keep it short, but interested in the question of authenticity in algorithmic choreography.
Yeah, I mean, that's a really good question. Like, yeah, I guess the question is, what makes it authentic? Are you like, yeah, trying to is copying what the computer does make it more authentic, or does being more or interpreting more as a human make it more authentic because then you're being more of yourself? Like, I guess, like, what needs to be authentic? Would like, yeah, it could be either way.
Yeah. And Mark asks, how do the dancers handle the interface between you and them? Is the screen a good interface? Have you explored other options, maybe an earpiece, Google Glass, wearable haptic feedback?
Yeah, so the first piece of mine that I showed was actually, that's a haptic interface. There's no screen involved in this piece. So I have explored that. I've done, and then the projection or the screens, I've done, you know, 4 small screens on the corners. I've done projections on the floor that rotate so the dancer doesn't stay like static facing front. I've basically, I haven't done an earpiece, but I've done verbal instructions that everyone hears. I've done pieces where I just read into a microphone. Like, I've kind of done this like every way. I haven't done Google Glass. That seems like the most problem for a dancer. I just imagine it flying off the second they like turn. But yeah, the haptic feedback was really interesting in terms of showing it at a live coding conference. Like, the first person to come up to me after the piece actually kind of like really intensely in my face was like, why didn't you show your screen? And I was like, that wasn't the aim of this, but thanks.
Live coders.
Yeah.
Yeah, that's funny. Do you have a preference, or do you think there's one of those ways of working which work better or worse?
I mean, I actually really enjoyed when it was just sort of these 4 small screens in the performance space. And I've done that a couple times. I also did one where, actually at the Opera House in Malmo of all places, where the dancer had a monitor in the front of the stage for like the first half of the piece, and then the second half, the projection slowly came in, so it was kind of revealed to the audience that they were following the score that was being generated. I kind of liked that because it was very theatrical and very like, all of a sudden, oh yes, of course. There's a reason why there's a woman at a laptop on stage too.
Oh dear. I think that's us out of time, but thanks for sharing that work. It was super interesting. Yeah, I really want to look at those examples you showed. The Brazilian one also looks super interesting. So yeah, I think we'll carry on this discussion on the forum. But yeah, thanks for your talk.
Thank you, and thanks for bearing with the child.
It's no problem. Sorry, yes. So the next talk up is Simon Blackmore, who hopefully you're here. I will just make you presenter. Oh, you're already presenter. Someone else is on the job. You don't appear to have any mic right now.
Great, I should have it now, right?
Yes, that's great.
Good. Okay,
Great.
So I just need to work out how I'm going to share the video. And is it the plus sign I press?
Yeah, if you press the plus at the bottom, and then it should give you an option to share video.
Great. Okay, I'll do that in a second. So, hi everyone.
Now muted.
Thanks for having me on this great conference. It's really been amazing so far. I'm going to try and present to you a project called Crypto Guitar, where I've got a guitar like this. Can everyone hear that? A nylon strum guitar, and I'm kind of been trying to code with it, and yeah, I'm going to show a video because it's too much technology to try and show you through this kind of live stream. So I'm going to put a video on in a sec, but I just wanted to just introduce it basically very quickly. That so the idea is that you code with this hand only, if you can see it. And just a quick anecdote that so the famous flamenco guitarist Paco de Lucia once said, someone asked him about the two hands that play the guitar, because obviously you have the left hand that controls the notes and the right hand that controls the rhythm, and he said the left hand is the intelligent hand and the right hand just does it, which is kind of interesting because it's like a crazy complicated stuff it does in flamenco. But yeah, so in this work, the kind of hand is coding and the left hand is just can play melody. So I'm going to put a video on to show how that happens, because it'll be much easier. And then I'll just finish with some thoughts after that. So if I can just do this. Oops. Hopefully this will work.
So this is kind of the heart of the project. It's like a rhythm translator. Into ASCII characters. So if I plug it in, I can talk you through it. So it's got this micro USB connection there. It's going to my laptop, and my laptop thinks it's a keyboard because the Teensy can be set up to mimic a HID keyboard. And it's got a MIDI input, which you can see coming in there. Now I use this to kind of send clocks and note-ons from devices to it. So, and I've got Ableton running on a laptop here that's going to send a clock out. So if I just start that up, you should see it running. Here we go. So I found this a really nice way to run things, because it means I can kind of do things like connect up two of these units, for example, and I've done that with a piece where I had two drummers drumming text, and I just had them both slave to one kind of instance of Ableton to clock them. And yeah, so the other thing I can do is at the same time I'm just sending trigger notes on from a set of claves, which with a piezo taped onto them here. So I should be able to hit those, and I can kind of start putting in information. So I'll just try and write something.
So that's how you write hello in these with these sticks. And the peculiar thing about it is I've actually been quite strict to copy a serial connection. So it's got the stop bit here and the start bit at the beginning. So the start bit never gets played, but the stop bit kind of does, to produce a character, which is a bit counterintuitive, but it means that you can kind of put in rubbish, and then if you don't put in the stop bit, nothing will happen. But if I go, I kind of got a full stop. And so, for example, to do the letter A, I go, B is C, and you can kind of go all the way up through binary. Then the numbers are, that's number 1, and you can go through the numbers. But I think I'll move on to showing you on the guitar now. So I've got this beautiful flamenco guitar here, and this is what I kind of played for playing flamenco, and I was interested in how you could pick up each finger movement and control a binary digit with this finger, because what's interesting in many types, on guitar music, is quite often you have repeated motifs on the right hand and the left hand sort of free to change for melody and that kind of thing. So this is a kind of rhythmic project in that sense. And so picking up the strings isn't that easy on this type of guitar, because it's a nylon string guitar, and you generally use magnetic coil pickups on electric guitar strings. That makes it possible to pick up every string, but on this, no. So I made this sensor, which is an optical sensor that I plug into a sound card. But to be honest with you, it's not brilliant, and bashing my guitar there, which you can see is a problem with this sort of thing. Like, introducing technology to a really nice guitar is problematic in so many ways. So I've been trying to make it as discreet as possible, but actually more recently I've been using a Godin guitar, which has kind of a built-in what's called a hex pickup, so each string's picked up individually through a piezo, and that works really well going through this Fishman wireless controller here. So this is kind of the best option to kind of actually get clear signals. Okay, so I've shown you the translator and I've shown you the guitar sensor that I'm using. Now, remember, it's just picking up the impulses from here, so you should be able to see that kind of doing something there. Yeah. So it's kind of, every time I touch a string, it's plucking a 1 or nothing if I'm not plucking anything. So yeah, so now I can write things. So have it, the word when. So I've been really interested in this idea of making sort of kind of bits of text and then converting them into rhythms, playing them, trying them. And what's nice is you can kind of play the rhythmic pattern with this hand, but then change the notes, as it were. So if I just do the W, for example, that's what I just played. But if I could change that to and so it's really nice to kind of get in the flow and just start trying to think of ways to do this and just start playing and then changing the left hand. So that's all I've got time for now. I'm going to show you some live coding. Okay, so I've just set up to do some live coding in Superglide, and I've got a really simple sort of patch going on here where if I put in the key, the ASCII code R, it's going to set it to record into a buffer, Superglider that is, and then if I press P it will play it back, and then Q it will do a quarter speed playback, H a half speed playback, and something I started playing around with to kind of get a level of complexity, and rather than just triggering loops, to sort of do this sort of live looping, became quite a fun thing to do. So I'll just try and record something now. So that should have recorded it. And then I can play it back by... so now, yeah, I can just play a bit if I try going on it that way. And D was set to play double speed, so you kind of get the sense that yeah, you can build up these kind of complex layers. Something that I've kind of enjoyed doing.
You are now unmuted.
Brilliant. Okay, I'll just recently I've been using. I'll just pause it there. Yeah, so that was my. That should show you how the kind of thing works and what I've been playing with. I guess I wanted to just end on a couple of kind of reflections and things that I've been thinking about, and things that have come up, you know. So one problematic or interesting thing being that forcing the rich complexity of an acoustic instrument into such a kind of narrow binary kind of world is often frustrating to people, I think. People would ask, why not use pitch? Why not use timbre? All those other things. I kind of purposefully wanted to keep it simple because I wanted to kind of work on the constraints of the rhythmic patterns, and I found that really interesting. But obviously, there's different ways it could be explored. The other thing I'm kind of thinking about really is there too much sort of cognitive processes going on in the whole thing? So both as a kind of player and someone watching it, and it's something that Anne mentioned yesterday, which was the idea that yeah, maybe there's just it's just too complicated. So yeah, I mean, I've been in situations where I played it once live in Spain, and I got this thing where I was trying to play a word and I couldn't get the word out, and then I didn't know what to play the music, and you kind of get this sort of like cognitive overload, which kind of made me start to think, how important is it to actually see the text appear? Obviously it's nice, but at a certain point maybe it's best just to leave it and just be happy with the code and the music and compose and that kind of thing. So that's kind of what there's a tradition of that within classical music called cryptograms, where people like Messiaen and Bach did this sort of way of composing through using structures and particular kind of rhythmic patterns and that kind of thing. Yeah, so I think I'll leave it there. I'm not sure what my time is, so if anyone wants to pop up and join me, that would be nice.
Sorry, I totally forgot to. It's nice feedback.
Brilliant.
Sorry, I forgot to give you the time warning.
That's okay.
That was like super interesting. I was just like thinking through the whole that it must like take so much practice to learn the binary patterns, the rhythmic patterns.
Yeah, and I didn't really mention the fact that what's nice about it is how, in a way, putting these melodic phrases onto it becomes a really interesting way they become like mnemonic devices to remember a phrase. I couldn't tap out a lot of the rhythms, but then I can start playing the tune and I'm like, oh yeah, that's it. And that kind of reminded me of stuff that was going on with the singing yesterday, using the sort of the song as a way to remember the pattern and that kind of thing.
Yeah. Yeah, I didn't think of that actually. That is much easier to remember a rhythmic pattern if it also has the pitch element. Yeah, I also kind of wondered about this sort of like the improvisational fluency, because it feels like if you're having to use the instrument that you're improvising with to input the commands for the looper, that's also like looping the sound that you play. I wonder how that affects you in terms of sort of being able to like really improvise.
Yeah, that was the kind of thing I was getting at with the cognitive overload. But it's like a nice way of, I started doing it just because I kind of felt that, you can write text and that's nice, and then you can. I did some stuff with triggering loops. So if you sort of start to just sort of, do playback and record and stuff, you kind of start getting sounds that you kind of are surprised by, and that made me think. I mean, it's an interesting question for live coders, like what do you want out of a computer? And because in a way you want some kind of surprise, otherwise there's no point in doing it. So it's kind of a way of entering that world of kind of, because otherwise I just find myself a bit bored by just, actually I can find a lot of pleasure in just writing the same letter over and over again, but kind of another aspect that's kind of got multi things.
Yeah. Let's go to the question from Jack. Your system is extremely constrained in an interesting way. How did you arrive at this level of constraints, bracket, not more or less?
That's kind of an interesting question, because I basically made the circuit and used my voice, and then Alex just pointed out, I did a piece with the two drummers for Algorithmic, so it's basically that kind of reusing a piece of technology again, but yeah, and then I think I'm just trying to remember the book. I think it's Adam Evans. I've got it here somewhere. This kind of, I was just really thinking about this idea of how do these just digits relate to the digital, and just kind of, that idea of plucking zeros and ones just seemed quite a beautiful kind of idea to me, and I just thought I'd just do that. And like I was saying in the kind of reflection that, there's so many ways you could approach this kind of thing with sort of sensing, using machine learning sort of stuff and just remembering patterns, and certainly people have said that to me, just saying, oh no, you're the wrong way about this, you should just like play a guitar phrase and get a computer to listen to that and work it that way. So but like I said, I think the thing was that I'm kind of really interested in those sort of how those patterns just get used, and in flamenco, for example, there's particular kind of rhythmic patterns that just get reused over and over again, and that's what it's all about, and just having a really good underpinning of that. So I kind of was thinking about that in relation to this sort of kind of more weird computer binary pattern code.
Super interesting. Manuel also like did a super nice question, but I think we're over time, so we'll have to move on. Hopefully you can answer that via the forum.
Brilliant. I'll make sure I get into the forum and chat there as well.
Super. Thanks so much for your talk.
Thank you.
So next up we have Chao Lan, who I can see in the list of people who are here, and I'll just make you, already presenter. Great. So yeah, you can just go ahead and start your talk. I don't hear you. I don't know if your microphone is turned on.
Yes.
Good.
Thank you. I have already recorded the whole presentation, so I'm going to share the video. Hello everyone, my name is Chao Lan. I'm currently a PhD student at the Rhythm Center in the University of Oslo. Today I'm very glad to introduce you the live coding environment called Choreography and the interface for embodied pattern environment. To begin with, I would like to first give you a brief introduction to the live coding environment. So as you can see, this is a browser-based live coding environment, and you can just visit this adjust to access to this live coding environment. And it features the concept of new. So by entering a name, then you can create a password and collaborate with your friend. But today, the focus will be on the language side. Well, this live coding environment actually runs the domestic language of the same name. So Cordeiro series is a functional programming language, and we write code like this. So this is loop function that creates a node sequencer, and I would like to connect it with a sawtooth sinks to form a function chains. And I can further connect it with an amplifier effect. It sounds like this. To create a modulation for the amplitude, I can write something like this. So this is a concept called
You are
reference.
now unmuted.
So I'm currently modulating the amplitude with a
You are
square
now muted.
LFO. I can make it synchronized to the eighth note. So the slash and the eighth note means a symbol, which I will show you something later. And I can set a low number to be 0.1 and max number to be 0.9. And it will sound like this. So the reference in Cordeiro series can be quite flexible. For example, I can give a reference to this loop function and reuse it in some other function chains. I can even write something like this. I can change the speed of the pattern. And here I'm going to use a function called sampler. I'm going to choose this beta AHC sample. Here underscore means I'm going to use the default value 0 to choose the first sample. I can make it louder. You can even use the reference to denote a note. So in this example, I'm going to use a choose function for note A. And 0 means rest, and the numbers here, like I have 3, 60, and 5 zeros, that will change the probability. And for node B, I'm going to use just a range of this. I can change the BPM. So these are some fundamental features for the Cordeiro series syntax. But the focus today is what kind of pattern we can create with this loop function. So to expand that, I'm going to enter a term called pattern. So I already created several patterns to illustrate it. So I write it in this way to make it easy for me to comment in and comment out. So when we have a default BPM of 120, that means the total length of one bar is fixed. So the number of MIDI notes after a loop function will equally divide this one bar into, say, 4 pieces in this example. You can use an underscore to denote rest. And if you write more MIDI notes in one loop sequence, it will influence the share of each note. So this third example will definitely sound faster than the first example. And you can even further divide one part into smaller pieces. So in this example, compared with the second example, I divide this third part into 4 elements, which includes 2 MIDI notes and 2 rests. And you can divide it into any pieces, say 5 or 7. I can do some live coding here. So this pattern representation in Cordeiro series is actually inspired by both an ancient Chinese drum school and tidal cycles. So when I write the note representation in this way, it's actually quite straightforward. But when I further divide some parts into smaller pieces, there are some algorithmic things coming in, which will definitely remind you of tidal cycles. But in Cordeiro series, we only support 2-layer division or nesting, whatever you call it. So this is the drum score I mentioned. It basically documents 2 patterns for playing 2 different kind of drums. The first one is called loop drum in right circle. The other one is called shear drum. And the pattern is very straightforward. There's no concept like timing or BPM or anything algorithmic. And this score is actually very old. It's around 200 BC. And Basically, it means that you should use your body to play the pattern. But here I summarized 4 types of pattern writing. The first one is I know what to do. For example, the flat 4 thing, I can just input 4 MIDI notes. And the second one is I want to try different patterns. For example, for this one, apparently I was trying different patterns. And the third is I let the computer design. For example, I use the choose or range function for that. But the question is it possible to use the instinct for my body to write the pattern? So it brings us back to the algorithm I mentioned in the abstract. The question is, when we have a pattern, we can convert it to a relative timing list for the computer to play the note. So in the first example, I have 2 notes to play. So one is divided into 2 parts. The notes start at time 0 and time 0.5. And we can times the length of 1 bar, right? And the second example, there are 3 elements. The second is a rest. So we only have 0 and 0.666. And this third example, compared with the first one, it also has 2 elements. But the first one is a rest, so we only have 0.5. And this example requires some calculation because the third element is in between 0.5 and 0.75. So it becomes 0.625. And the question is, if we record some keyboard input, say a combo or a shortcut, and we record the key down time, and we set the first input to be 0, and we calculate the difference of the rest of inputs, and we divide it, we divide them with the length of 1 bar, and we get a list like this. It's not accurate, so that's why I call it humanized time points list. And the design pattern is something like this. So as you can see, it's the reverse order of this 4th example above. But how should we calculate it? How can we design an algorithm to for the pattern inputs like this? So in this pattern notebook, so in this Python notebook, I only have 3 functions. The first one is to convert the pattern to time. So it's something like this. And the second function is called humanize it. It will just create some, give some randomness to the result. And the second function is called humanize it. It will just create some, give some randomness to the result. And the second function is called humanize it. It will just. Hello everyone, my name is Chichaolan. I'm currently of inputs, and we divide it. We divide them with the length of 1 bar, and we get a list like this. It's not accurate, so that's why I call it humanized time points list. And the first one is to convert the pattern to time, so it's something like this. And the second function is called humanize it. It will just create some, give some randomness to the result time list. And the final question is called time to pattern. That's the solution we are going to discuss. So it basically creates a 2 range from 0 to 7, and it creates 2 for loop to form some grid, say 4 times 3, and it creates the timing grid or timing list, and it will compare the time list with the recorded input keyboard timing list. And when the difference is below the threshold, it will choose that search result and start to print out the pattern as a string. So here are some results of the algorithm. And in this first example, the pattern we give is something like this, and the humanized timing list is something like this, and the computer generates a pattern like this. And if you calculate it carefully, you will realize that it's basically the same thing. The reason why it looks very strange is that the computer starts to search from 0, and that's kind of that will make the computer tend to use less spaces, and it's kind of against our pattern writing habit. But it's quite interesting, and it actually reminds me that I unconsciously developed this writing habits when I write some patterns. So I first want the first thing I try to do is to use the space to divide 1 bar into different pieces, and then I will try to use the combination of underscore and the number to divide the part into smaller pieces. So in this second example, we have 4 parts, but the computer only try to use 2 parts and add a lot of space. And if we reflect it, well, if we are required to write something like this, it will require a lot of calculation. So it seems that we still tend to use some intuition or embodied kind of feeling rather than to calculate everything when we write the pattern. And the same phenomenon also happens in the third example. We will never write something like this, right? So That brings us to this final discussion. I have two questions for you, actually. Is it against the essence of programming when we use our body to input the note pattern? And the second question is, when the algorithm is implementing other language, for example, Super Collider, you can just record the exact duration, exact pitch. But does it feel nature to generate code like that?
Okay. Hi.
Do you want to say anything else, or do you want to go to questions?
Yeah, we can go to a question.
Thanks for your talk. It's like super interesting project, and I saw you performing with the SEMA version recently, and it was like a super nice performance.
Thank you.
Let's go to the question from Alex. I missed the part about the ancient Chinese drum score influence, which looks super interesting. Could you explain that a bit more, please?
Well, actually, I'm not sure if I can upload the picture. I'm uploading that. Can you see?
Yeah.
Yeah. Yeah. So actually, there are not so many documents about this drum score, but as far as I know, it's probably the earliest score in all instruments in Chinese history. So in this score, we have two drums. So it's the name of the drum. The better draw it with a different color. So we have the name, the drum of the name here. And I guess I'm not sure whether the circle represents a hit or is it the square represent a hit, but it's a pattern there. And here, this character means half. So probably the player should divide the pattern into two parts. I'm not sure, but yeah, that's all I know about this score actually. Yeah.
That it's not a score that anyone would still use for any traditional drumming practices? No,
actually, we don't know exactly how these two kind of drum look like right now. So we only have the score. Yeah.
That's super interesting. Can you, sorry, you had two questions at the end, but they sort of disappeared too quickly for me to remember what they were. But maybe it would be interesting to discuss those. At the end of your presentation, you had this slide with two questions.
The first question is when we use our body, when we record the time of keyboard key down and try to use that timing to enter a pattern. I'm asking. I was asking, is it against the sense of programming? That's the first question. And the second question is it possible to apply this algorithm to some other programming, live coding language like Super Collider or tidal cycles? I want to hear your opinions on that.
I don't know if anyone wants to come in with an opinion there. I mean, didn't you recently make the same programming language in the same system in SEMA, right? So that was already transposing it to a new language.
Yeah, but in that version, I haven't implement this pattern writing thing. So I focus more on the sound synthesis in SEMA system. Yeah.
Okay, nice. Yeah, it'll be interesting to see how it turns out if you're planning to carry on implementing the whole thing. Paola had an interesting comment. Thanks so much. This will help me a lot to solve some things related to patterns in the Kipu I'm developing, which, by the way, I need to point out, there were also similar devices, not based, found in China.
Wow, I haven't known that before, so I'm going. I will definitely check it. Yeah, thank you.
I can see Jack and Paola are writing questions. Jack, isn't what you're doing similar to quantization, going from continuous to discrete?
Yeah, but I guess I think why I ask that question is because in tidal cycles or in supercollider we have to think. It's actually quite related to the research in Whitmore Center because based on the research of my colleagues, they found that expert instrument players tend to think less in their playing. But I asked the question, it seems that live coders think a lot during their performance. So, but what are we thinking? Probably we are thinking how to write the pattern. So we don't use the embodied timing in our pattern writing. But when I have the algorithm like this, it seems that it change the way we organize the pattern. So that's why I was asking that question.
Yeah, great. Yeah, maybe we can keep reflecting on those questions in the forum on this because we're out of time. But thank you very much for the talk.
Thank you.
Thanks.
Cool. So should I stop sharing or something?
Yeah,
Okay.
I can switch Sol to presenter.
Okay, can you hear me all right?
Yeah, you're a little bit quiet. I don't know.
Okay, yeah, I unfortunately have a pretty limited setup because I'm traveling. I hope it's fine. I'll try to speak up a bit. Okay, this is the screen share.
Great. So this is the final talk in this this session, and it's from Sol Bikic. Yeah. So I'll just hand over to you to introduce yourself and give your talk.
Okay. Yeah. My name is Sol. I didn't prepare an introduction. I do various things, hardware and software based, dabbling in a live coding language that I've been working on. And this is about that. It's about this live coding interaction approach that kind of came out of that I've been calling persistent expressions for now, and kind of how this style of editor integration and visualization that I've seen others work on kind of came out of that naturally at the end. So this is the programming language. I'm calling it Alive. It looks something like this, so you can see the Lisp influence there for sure. And I'm going to talk about how this design kind of came to be. So it's mainly the project came out of me working with pure data sometimes before, and also trying traditional live coding languages, and then deciding to try to merge those things. So in pure data, what I really like is that you can see the whole program in this kind of Rube Goldberg machine way. So you see these particles that interact. And the representation that you as the programmer see and deal with is the same as a mental model that you can construct of how it actually operates. So you see individual boxes and you connect them, and that's also how they interact between each other. All state in the system is kind of localized and embodied into individual boxes. And that kind of makes it easy to reason about what happens when you delete something, when you add something, when you reload the program, maybe when you edit it. What I didn't like so much about working with pure data is that editing it is kind of clumsy. I'm a heavy keyboard user, and you have to switch to the mouse all the time to position things. Even if you're very happy about using the mouse, then you have to go in and type things all the time. And doing complex projects, it kind of can explode. Maybe I think there can be advanced techniques to kind of mitigate that, but I didn't know them when I worked with it. On the other hand, using languages like traditional live coding languages like SuperCollider and tidal cycles, which I also have little experience with, I have to say, what I really like is that with a text-based language as a developer, I'm able to express a lot of stuff very quickly, lots of content. I can edit it very fast, and you can really put a lot of stuff on screen, basically. What I don't like so much is that generally in these languages that I know, you communicate with the live coding process in deltas, so in individual changes, basically. You don't give a fixed you just give commands, essentially. So here you can see highlighted on the bottom these two lines. So if you look at this program, which is a SuperCollider program, like I would write it, like I know to write it, and then you can see I'm defining some stuff like a sequence here. And then just from the screenshot, you can't tell if that sequence is playing right now or not. You can see that I'm intending to stop and play it sometimes, but since I have to execute those lines iteratively when I feel like, you can't really tell what's going on just from the screenshot. And this is very different from pure data, where you always see what is actually happening right now. Everything you see at a given moment is what is happening, basically. So I try to kind of merge those two things, the texture representation and this visibility of the whole program space. So I created this text-based language that has general text-based features that you might expect, like functions that are basically just shorthands to generalize things, loops and things like that. But every expression is can be a stateful block, similar to pure data and data flow languages like that. And they all kind of execute in parallel after the initial evaluation of the program. They kind of keep existing and they can talk to each other the same way that values would flow through the Lisp language normally. And basically, the other big change is what I talked about before with textual languages. I didn't want to have that like iterative, like selecting of blocks and submitting them. So instead, you always submit the whole file. And if you edit an expression, then the runtime equivalent of that expression is created. If you delete an expression, it stops executing immediately. And any state of any sub-expression is automatically mapped to the new version. So for example, here on the right, I have two code examples as a before and an after. So before I have an LFO running at a half hertz. And then after I've changed the frequency here to 0.3, so to a third hertz roughly. And since this LFO has the same tag here, which identifies uniquely that expression in the program, that LFO is not going to be reset to the beginning of the phase cycle when you save the file, but it's going to keep running smoothly with a change in speed. And then also you can see here that I've wrapped in this example the LFO into another expression. And that LFO, if you think about like a pure data style system, that would constitute like a change link on the bottom that can happen at any point when you save the file. So you can rearrange the file however you want. And these tags that I've added to the language, they help the live coding process kind of map things back together, so that if you don't change anything in a particular block of the program, then the result will stay the same as if you didn't change anything, but you can make any transformation that you want, just like you can do through direct manipulation in an individual block-based language. And so what came out of this is that since I have these tags that uniquely identify expressions, and since each expression has or can have state, I can turn that into editor visualization that is quite useful and that is something that you have in pure data too, to have like, there's an event firing somewhere, you can have an indication of that visually. For example, so basically I'm doing this as an experiment in Atom, and Atom has this tree sitter. It's called library for parsing languages built in, and this is the Lisp syntax, the S expression syntax is quite easy to parse, so that's not a big problem to parse these expressions, extract the tags, and then I can basically ask the running program about the state of each expression. And each expression can also tell me if it has a preferred way of being visualized. So here, for example, there's a switch expression, and the switch expression, the editor knows that the switch expression likes to be visualized like this to highlight the current validated outputs. something like an event generator, like this every 0.6 seconds automatically gets visualized as this pulsing pattern that reacts on the trigger of that event. And then I have also a library of visualization that you can use wherever you want to use, for example, this bar visualization to highlight, to visualize any number. And yeah, I have other things there, like visualizing an RGB color just as a color field and things like that. So yeah, so this is kind of what came out of that. And this is pretty work in progress, this part. I've been working on the whole language for about a half year now, on and off as a side project. And this edit integration thing is really new. It's like a month old. I've been thinking about it in the back of my mind, but I really started working on it a month ago. And this approach really could also be used for more, for other ways of integration. So, for example, since the program is always there in the back and there's an established communication channel and also a way to address any individual expression, I could also ask, for example, what symbols are valid, are defined in at a specific point in the tree structure, in the syntax tree. Which is just, you know, like an autocomplete could be done. It doesn't have to like statically analyze the whole program and try to be smart about what are the options at a given point, but it can actually ask the interpreter that has the ground truth on that. So yeah, that's what I have for now. Thanks for listening. I'm gonna stop screen sharing because I will go back to the other screen for that. And yeah, I'm happy to take questions.
Sorry, it always takes a minute for the video to load. Thanks for that, and thanks for showing us your project. Super interesting. I wondered if you wanted to start by reflecting on the topic of hybrid live coding interfaces and how your work is related to that topic and the call that we put out.
Yeah, so I built this. Basically, this language started out of the first version of this was a block-based language that I made to do VJing, actually, which I have a bit more experience with than music. So this is really, or it came out of, it kind of turned more towards sound based on people I've been around who've been asking about that. But this was meant more to be a kind of a glue language to glue my MIDI controller to shaders I have run, to kind of build a tool that is you know, performed directly, more like a traditional instrument, but for visuals. To which I really thought that's how I got to the idea of using a text language in the first place, because I think it really fits there. So you can easily describe like kind of a transformation from like a range of inputs to another range of outputs. And then you can do like the detailed, you know, fast-paced, fine-tuned, like high fidelity and in time and also in control. Yeah, kind of naturally with your hands.
Yeah, I think that was one of the videos that you sent in, wasn't it? With the like flicking between being able to move around the code with some interface.
Yeah. Oh yeah. I built kind of a physical editor at one point, kind of like a structural editor. You think about the downside? I'm reading the question here.
I'm just going to read it for the YouTube audiences. So someone's asking, what do you think about the downsides of having a parentheses heavy approach?
Personally, I don't mind it so much. I think, well, a good editor can help a lot with that. So a purpose-built editor can definitely, so visually you can mute them. You can have a more ergonomic key, maybe if that's an issue. To type that key so much, but I think basically any programming language will have a lot of punctuation. Maybe it's a different character, but it can be tricky to kind of deal with the nesting of things. There's a really nice project that came out of, I think, Clojure that is called PowerInfer that kind of does this, it kind of combines the parentheses management and the white space management similar. So it ends up working kind of like Python, and it moves the parentheses around to match indentation or the other way around, so you don't have to think about it as much, as it's not so cognitively heavy.
Yeah, I think that's super helpful. I think like sometimes with I haven't used Lispy languages that much, but also with SuperCollider and like the pattern side of the language, sometimes you end up with like endless like nested brackets inside of nested brackets. So yeah, there's definitely a need to like manage that somehow in
I would have
performance.
definitely chosen another approach if I would have seen a viable one. The thing is that since I'm using these tags to identify expressions, I really need clear boundaries, and I wanted them to be very easy to see for the user, and also very easy to parse for the editor. So this was the most natural way at the moment for me.
Yeah, and Alex leading on from that quite nicely, actually, when we're thinking about sort of performance and dealing with these sort of complexities in performance. Alex is asking, have you performed with it yourself or shared it with others yet?
I got quite carried away. I haven't really had time to practice much with that, and I haven't performed publicly with that. I really hope to do that soon, and it is public, so the code is public, and also documentation. It's work in progress, but I think it is quite accessible at the moment, and I'm happy to answer any questions and help people get started with it. I'm not sure if I can try to share the screen again for a second just to show the links at the start of the presentation. If you want to pick that up. So the domain is here, the website with documentation and links to source and things like that. And I recently set up this mailing list with like release announcements. I will be releasing a 1.0 soon with kind of a lot of changes that have piled up. So if you're interested, that would be a good time to check it out, I think.
It's always a great way to test your software is when it goes out into the wild.
Yeah, definitely.
Hopefully we get some interested people through this workshop. Simon's accidentally turned his mic on. Ah, great. That was a fun so I'm just going to check if there's any more questions on the YouTube, and there aren't. So I think we're just about out of time anyway. So let's just move this one also to the forum, and then give ourselves a little bit of a break before the next session.
Thank you very much.
But yeah, thank you so much for your talk. So that was our last talk in this session, and I believe Jack is going to take over for the next session. Oh, and Alex is back. Hi, Alex.
Yeah, I just thought I'd say don't forget to switch to the different stream. I posted the link in the YouTube chat, but we'll go offline for a few minutes to collect our thoughts. I've got to adjust my makeup and yeah, continue with Jack. So I'll stop streaming now, but please do join us in the new stream.